This Christian holy relic is referred to as the Shroud of Turin.
The Shroud of Turin is this amazing relic. At bottom, it's a piece of cloth. It shows a very faint sort of image of a crucified man.
The image on the cloth appears from both sides of the body. The front of the torso is visible on one half, while the back of the body emerges on the other. What remains is not a solid figure, but a faint shadow-like imprint, the unmistakable outline of a crucified man. For countless observers, this image echoes the story of Jesus' suffering, death, and resurrection. Now, thousands of miles away in a climate-controlled server room, a supercomputer is at work. It is analyzing millions of data points taken from a single artifact, an ancient strip of linen measuring nearly 14 feet in length. Where the human eye sees randomness, the machine searches for structure. It filters noise, compares layers, and hunts for hidden order. Then, something unexpected happens. The algorithm halts. It has detected a signal. Artificial intelligence reveals a symmetrical pattern repeating across the surface of the Shroud of Turin. This is not a random discoloration. It is not an ordinary stain. What emerges is something far more deliberate, a repeating sequence woven into the fabric itself. Confronted with these findings, physicists began asking a question they had never thought to ask before. Could the world's most famous religious artifact preserve evidence of an event that released energy on a scale comparable to a nuclear explosion? Something modern physics still cannot fully explain using conventional models? What once seemed like nothing more than a painting suddenly looked like something else entirely: data. For decades, the explanation had been simple. The cloth, nearly 14 feet long, was dismissed as a medieval forgery, a clever artwork created to fool the faithful. A remarkable illusion, but nothing more. Then came the turning point. When artificial intelligence examined the microscopic irregularities in the linen fibers, it stopped. It found a signal. Beneath the faint, mysterious image of a man, the system uncovered a repeating mathematical symmetry. This was not something an ancient artist could have engineered by hand. More troubling still, no known natural process could account for it either. In the simplest terms, the AI revealed what can only be described as a digital ghost, an encoded imprint locked deep within the threads of the cloth. To understand why this discovery changes everything, we have to look closely at the details. The image on the cloth is incredibly shallow. It exists only on the very outer layer of the linen fibers, affecting just the surface microfibers. We're talking about a thickness measured in only a few hundred nanometers. For comparison, a single human hair is about 80,000 nanometers thick. The image on the cloth is thinner than a soap bubbles film. The coloration doesn't soak into the fabric like paint, dye, or ink. When a thread is cut and examined in cross-section, the inside remains completely white. Only the very top of the fibers shows a faint tan color. There are no brush strokes, no directional marks, no signs of pigment being applied by hand. Everything points to the fibers themselves being chemically altered, likely by an extremely brief and intense burst of energy. Faced with this complex matrix, artificial intelligence doesn't see a picture. It sees data. Neural networks apply advanced analysis methods, stripping away noise and isolating the underlying structure. And that's when something remarkable appears. An information field begins to emerge. Light and dark areas follow a precise, predictable rule, almost as if governed by a physical law related to distance. Imagine a cloth draped over a human body. If an artist tried to recreate that scene, they would rely on painted shadows to fool the eye. But this image doesn't work that way. The AI confirms that the intensity of the image matches the exact distance between the fabric and the body beneath it. Where the cloth was closest to the skin, the image is brightest. Where it was farther away, the image fades. What emerges is not artwork, but a flawless mathematical map. And that's not all. The AI also detects subtle symmetry and proportion throughout the figure, It's like visual music. The spacing of the eyes, the proportions of the hands, the curvature of the ribs, everything follows an internal geometric framework. These patterns remained hidden for centuries, masked by the natural visual noise of the woven textile. The human eye never noticed them. The AI does. All of this leads to a powerful conclusion. The image was not formed by an artist pressing pigment onto cloth. And if it were the work of a forger, that person would have needed to be a physicist, a mathematician, and a nanotechnologist, centuries before any of those fields even existed. If this image were painted, it would require a form of geometry no human eye could see. But analysis shows that it behaves less like a drawing and more like a projection. Science has uncovered an unexpected possibility. The world's most famous object of religious devotion may actually function as an advanced information medium, created by a process we still don't understand. Artificial intelligence didn't settle the debate over the cloth's age. It made the debate irrelevant. Because even if the linen truly is ancient, the real mystery remains. How could three-dimensional information be encoded directly into individual fibers? It would be like discovering a QR code hidden inside a medieval painting. It simply shouldn't exist. AI reveals that this isn't just an image of a man. It's a document, one that contains measurable, verifiable data that humanity is only now learning how to read. The investigation goes even deeper. When AI analyzes the area surrounding the body, it notices something unusual. In most forgeries, the background is either filled in or deliberately concealed. Here, the opposite is true. The surrounding cloth contains almost no information at all. This suggests the image-forming process was highly selective, affecting only the areas where the body was present. Even more remarkable is how it happened. The formation appears to have occurred with extreme collimation, meaning the energy traveled in straight parallel paths, much like modern laser beams. If you shine a flashlight on a wall, the light spreads and scatters. That doesn't happen here. There is no diffusion. At the microscopic level, the edges remain sharply defined. This means the energy responsible for the image did not spread outward. It moved in straight lines, defying the inverse square law. Artificial intelligence flags this as a physical anomaly. What we're left with is a piece of cloth that seems to have recorded a moment when the usual laws of physics briefly stopped behaving as expected. The AI didn't just detect a pattern. It uncovered a map encoded within the mark itself. To understand why this discovery is so astonishing, we need to look backward. The shroud has been quietly holding strange clues for over a century. Let's return to the year 1898. In 1898, a lawyer named Secondo Pia took the very first photograph of the shroud. Inside his darkroom, as the photographic plate began to develop, he froze. What he saw nearly made him drop it. The negative revealed something astonishing. The faint, blurry image on the cloth transformed into a clear, lifelike portrait. In other words, the shroud itself behaved like a photographic negative, hundreds of years before photography even existed. That realization alone forces us to stop and think. How do you paint a negative when the very idea of photographic negatives hadn't been invented? An ancient artist paints what they see. They don't invert light and dark values so that a camera, centuries later, will reconstruct a realistic image. That would be like encoding a book in binary in the year 1300. And that was only the beginning. In the 1970s, researchers from the US Air Force Academy analyzed photographs of the shroud using a VP-8 image analyzer. This wasn't a novelty device. It was advanced technology developed for space exploration, used to convert light intensity into three-dimensional terrain maps of the Moon and Mars. When a normal photograph is run through the VP-8, the result is chaos. Faces become distorted, noses sink inward, eyes bulge unnaturally, and the image collapses into nonsense. That's because standard photographs contain shadows created by light sources, not true depth information. The analyzer misreads those shadows and invents false relief. But when the shroud image was processed, something entirely different happened. The distortions disappeared. Instead, the machine produced a clean, accurate, three-dimensional relief of a human body. Scientists were stunned. The image clearly contained real spatial data. Darker areas corresponded to parts of the body that were physically closer to the cloth, while lighter areas represented areas farther away. This is the heart of a mystery that has troubled researchers for decades. On one side, the cloth appears ancient. On the other, it contains information that behaves like advanced imaging technology, far ahead of its time. And this is where artificial intelligence re-enters the story. AI didn't just confirm the VP8 findings, it refined them. Neural networks filtered out visual noise from the linen weave and damage caused by the fire of 1532. What remained was a precise topographic map of the human form, free of anatomical distortions. And within that data, the AI uncovered something even more unsettling. The imprint suggests something extraordinary, that the body did not simply rest against the cloth, but somehow passed through it. This idea is often described as a form of volumetric projection. For a brief moment, it appears as though energy or radiation was emitted from the body itself. That energy moved through the linen, leaving behind a faint tan that encodes distance in 3 dimensions. Artificial intelligence observed that this discoloration is remarkably uniform. It does not soak into the fibers. Instead, it exists only on the outermost surface of the threads. If an artist had painted the image, pigments would have penetrated deep into the fabric. If a forger had used heat or a heated statue, the damage would have spread through the cloth and bled outward. But that isn't what we see here. Everything is vertical, sharply defined and preserved at an exceptionally high resolution. The analysis shows that whatever caused the image acted in straight lines and was unaffected by gravity. Then there is the question of the coins. For years, researchers noticed faint circular markings over the eyes, shapes resembling Roman coins issued under Pontius Pilate. When the AI enhanced contrast in the eye region, it detected circular distortions matching the size and shape of those coins. If accurate, this detail would date the event to between 29 and 36 AD. An ancient forger would not only need to know which coins were used during that exact period, but also place them with such precision that modern computer analysis would be required to detect them. The AI also examined the blood. It was not paint. It was real human blood, type AB. Even more striking, the blood has remained red. Normally, blood darkens over time as it oxidizes. A red color suggests unusually high levels of bilirubin, a chemical released by the body during extreme trauma and torture. More telling still is the sequence of events. The blood reached the cloth before the image formed. There are no image traces beneath the blood stains. The blood soaked into the linen first, and only afterward did the image appear. If this were a painting, the artist would have had to apply blood, then somehow create a negative image around it without disturbing it, a level of precision far beyond what a human hand could achieve. In this way, artificial intelligence effectively rules out the painter hypothesis. It simply does not fit the data. What remains is a piece of linen that behaves less like a canvas and more like photographic film, exposed to a form of radiation that is rarely, if ever, observed in nature. The implications of this are enormous. If the image truly records an event, then something physical must have occurred within the body, something powerful enough to release energy. What artificial intelligence may be detecting are the lingering traces of that energy signature. For many people, however, the story seemed to end in 1988. That year, 3 laboratories, Oxford, Zurich, and Arizona, performed radiocarbon dating on a small sample of the cloth. Using a technique called accelerator mass spectrometry, they counted carbon-14 atoms to estimate the fabric's age. The method is normally extremely precise. Their results placed the cloth between 1260 and 1390 AD. The headlines were immediate and decisive. Fraud, medieval forgery, case closed. But the problems began almost right away. The sample itself was the issue. To avoid damaging the cloth, researchers removed a tiny piece from one corner. But consider what that corner had endured. For centuries, the shroud was displayed publicly, held by its edges. Thousands of hands touched it. It absorbed smoke from candles, moisture from sweat, and even survived a devastating fire in 1532. After that fire, a group of nuns repaired the damaged sections. They stitched the cloth onto new backing material and performed an extremely fine, nearly invisible reweave. To the naked eye, the repaired areas were indistinguishable from the original fabric. Years later, Raymond Rogers, a chemist who had been part of the original research team, examined leftover threads from the 1988 sample. Under the microscope, what he saw was startling. The fibers from that corner were chemically different from the rest of the cloth. Those threads were coated with plant-based gum and woven together with cotton. The main body of the shroud, by contrast, is pure linen and contains no cotton at all. Rogers also detected traces of dye, used to colour the newer threads so they would visually match the older fabric. His conclusion was unavoidable. The laboratories had not dated the shroud itself. They had dated a medieval repair. It's like trying to determine the age of the Great Pyramids by testing a plastic cup left behind by a modern tourist. The result would be modern, not because the monument is young, but because the sample was wrong. As a result, the 1988 dating was seriously called into question. More recent technology has opened new paths forward. Using wide-angle X-ray scattering, scientists examined how the cellulose structure in linen breaks down over time. Unlike carbon-14 dating, this method isn't affected by contamination, repairs, or added threads. It looks directly at how the fabric's atomic structure has degraded with age. The results were striking. The level of deterioration in the shroud's linen closely matched that of fabrics discovered at Masada in Israel, materials securely dated between 55 and 74 AD. And with that, the timeline was no longer as settled as once believed. Another independent study, using vibrational spectroscopy, reached the same conclusion. The linen appears to be approximately 2,000 years old. The analysis didn't stop there. Artificial intelligence added another layer of comparison by cross-referencing the data with the so-called Shroud of Oviedo, a small cloth preserved in Spain that many believe was placed over the face immediately after death before full burial. Historical records for the Oviedo cloth exist that predate the supposed medieval origin of the shroud by more than a century. When the AI compared the bloodstains on both cloths, the results were striking. They matched perfectly. The blood type was the same. When the facial image from the shroud was digitally overlaid onto the Oviedo cloth, the geometry of the stains aligned precisely. This strongly suggests that both pieces of fabric covered the same face at roughly the same time. If the Oviedo cloth predates the Middle Ages, then the shroud must as well. And this creates a serious problem for the forgery theory. Anyone insisting on a medieval origin would have to explain how a forger, working centuries ago, somehow produced a nanoscale image containing embedded three-dimensional topographic data, matching the atomic aging of ancient linen and aligning perfectly with an entirely separate cloth preserved in Spain. That scenario borders on the impossible. The fraud hypothesis would require a medieval artist to possess an ultraviolet laser laboratory, a particle accelerator, and advanced training in forensic pathology. Artificial intelligence set the dating debate aside and turned its focus to physics. And physics delivers a clear verdict. This object does not behave like a painting, and it does not behave like a rubbing. It behaves like a record of an event. The evidence doesn't point so much to the cause of death as it does to the cause of the image, something that appears, at least in theory, to be impossible. If the image wasn't created by paint, chemicals or contact, then something transformed the body into an intense burst of energy. That leaves one crucial question. How can a surface image be formed as a photographic negative encoded in 3 dimensions on linen without burning or damaging the fabric? This is where the most controversial hypotheses emerge, but they are grounded in data extracted by AI. The strongest scientific explanation currently proposed involves vacuum ultraviolet radiation. Researchers at Italy's ENAA research agency spent years attempting to reproduce the shroud's image. By exposing linen to excimer lasers, they discovered that a very specific short-wavelength ultraviolet light can create a uniform discoloration, affecting only about 200 nanometers of the surface while leaving the rest of the fabric untouched. But there is a critical limitation. To imprint an image across a full human-sized cloth would require an estimated 34 trillion watts of vacuum ultraviolet radiation. That is more power than any known terrestrial light source, or even a nuclear event, yet delivered without heat. The energy pulse would have to last less than 40 billionths of a second. Any longer, and the linen would vaporize. Any weaker, and the image would not form at all. It would require a perfectly balanced pulse. And that leads to a remarkable prediction, one that the AI-derived data does not rule out. The evidence suggests that the body did more than simply decompose, it vanished. Some physicists describe this using what's called a collapsed state theory, proposing that the body's mass was directly converted into energy. According to Einstein's famous equation, E equals mc squared, even a small amount of mass contains an enormous amount of energy. If the atoms of a human body were suddenly altered, the result would be a powerful burst of radiation. Artificial intelligence detected that the image is orthographic. The radiation appears to have traveled in straight lines, perpendicular to gravity, without spreading outward like a sphere. This points to a controlled, directional event, something closer to a biological event horizon where a system reaches a critical threshold and undergoes a phase change. Another supported hypothesis involves a corona discharge, a massive electrostatic event. Imagine a human body charged with millions of volts, releasing a plasma discharge strong enough to affect linen at a microscopic level. The AI identified high-voltage, fractal-like discharge patterns similar to L figures, which are sometimes observed after lightning strikes. And then there is the most radical idea of all, a higher dimension. Some theorists studying the 3-dimensional map generated by AI suggest the image resembles what happens when a 3-dimensional object passes through a 2-dimensional plane. Only a cross-section would be visible. If an object were to move into a higher dimension, the energy released could leave a shadow in our 3-dimensional space, one that, when recorded on a flat textile, appears as an image on cloth. It sounds like science fiction, yet no other known object exhibits these properties. There is another quiet but critical fact. The AI found no evidence of decomposition. Normally, a body begins to decay after roughly 40 hours, releasing fluids and gases that would stain, distort, and chemically damage fabric. None of that is present here. The body remained long enough for blood to settle and rigor mortis to occur. But then, it disappeared before decomposition could begin. The body did not move away. If it had, the blood stains would have smeared. Instead, analysis shows the stains are sharply defined. The linen fibers beneath them are undisturbed, no tearing, no shifting, no friction. Everything indicates that the body vanished from the cloth without disturbing it, passing through as if it were mechanically transparent. If this were an ancient forgery, the forger would have possessed technology far beyond even modern science. If not, then what remains may be the physical trace of a singular, unprecedented event. Artificial intelligence detected no brushstrokes, not one. What it found instead was the signature of a flash, an event lasting a tiny fraction of a second, yet leaving behind a record capable of surviving nearly 2,000 years. And still, the question lingers. Are we witnessing evidence of a phenomenon that lies beyond our current understanding of physics, or the most elaborate and incomprehensible deception ever created by humanity? Perhaps we've only just begun to uncover the science that is yet to be discovered.